Hi, and welcome to our literacy chat. I'm Stergios Botzakis. I'm a professor at the University of Tennessee, Knoxville, and tonight I'm talking about reading strategies and social studies and math. To start off, I just want to give a little background about what it is I'm going to be talking about, and that is disciplinary literacy. And really, I'm not going to read you this quote, but you can look at where I got the citation from. Basically, disciplinary literacy is something very important in secondary and middle school because we're training students to be conversant in subject areas and to be experts in those fields. And because of that, we need to go beyond content area literacies, which are more general, to the specific things that they need to know in order to participate effectively in their content areas. And a lot of tonight, I'm going to be talking about vocabulary. And I know this says reading, but as you can read in this quotation here, vocabulary is a huge contributor to reading comprehension. And it's very hard to parse those two apart. We often teach them as separate, discrete things, but they're really not. They are really very tied into each other. And in terms of subject area and disciplinary learning, vocabulary is huge if you think about it, because really we're teaching vocabulary in a broad sense. So when you take biology, you are learning what the word biology means in every aspect of it. And same with calculus, same with algebra, same with history and all those things. So vocabulary is a huge component of understanding the world. And tonight I'm going to talk about ways that we can use that in terms of reading comprehension or reading instruction in social studies and mathematics. And my foci for this talk are three things that I talk about them here individually, but really every activity I'm going to do tonight binds those things together. And what we're going to do is try to build background knowledge. We're going to try to build vocabulary, and we're just going to do research. I think all three of these things are necessary for actively engaging in disciplinary learning. So we're going to do four activities. I can count to four for my bullet points. One is called How Well Do You Know These Words? And that one you won't find in the research named as that, but that's what I call it. And then the other three are more typical activities: semantic feature analysis, linear arrays, and we're going to write some biopoems, which is going to involve research on the part that as you'll see. So one of the things we're going to do, the first activity, is called How Well Do You Know These Words? And I like this activity because it's good for previewing vocabulary. It's also good for reviewing vocabulary. And it's something you can use pre and post if you're doing a unit of study. I'm going to bounce out of my PowerPoint into my Word documents. I'm going to share right here. And I'm going to show you what this looks like. So I'm pretending for the purposes of this presentation that we are studying World War I. So I'm doing some world history, and this here is a chart. There are 4 columns and they're all labeled. You don't know it all. I've seen it or heard it, but I don't know a meaning. I think I know a meaning, and I know a meaning. The thing about vocabulary knowledge is that it's not an all or nothing proposition. You don't either know a word or not know a word, especially complex words. You know gradations of meaning, and you may have heard of something or have something that you know is related to it, but you don't necessarily know what it means. But you might realize what field it's in or might have an association with it. And this is what this activity kind of gets at. So if you're doing this on the front end of a unit, if you look below, here are 12 words that I would ask students to place up in this chart. And really what I'm looking for is how familiar they are with these concepts. And if I was doing this before teaching a unit, I would find out what things they do know about and what things they don't know about, which is a nice way of pre-assessing students. That way you know, going into your own instruction, what things students already have a grasp on that you can build from, and which things students really don't have a grasp on that you need to do a little bit more work talking about or introducing to them. And I put all these terms here. I'm not sure if you're familiar with all of them, if you're experts in World War I, but I would take a couple minutes, have students do this, and then review and see which things they think they know, which things they don't know, and try to build some kind of background knowledge. It's like a very simple way to do that. On the back end of a unit, you can not introduce this, but you could use this before you get into reviewing and give this to them and see, okay, do you know what these things are? And how well do you know what these things are? And in that way, you'll know what things students are really firm on and which things maybe they're shakier on. And that's just a nice way to do a pre and post kind of activity with vocabulary and content knowledge. And from our first activity, I did a social studies thing. I'm going to go into our second activity, which is it is actually a semantic feature analysis. And I'm going to do that in terms of a mathematics unit. And this here is a chart activity. It names items from a group, and then it shows their common and contrasting features. And one of the things about vocabulary, it's not just about what things are, it's also about what things aren't, and how those things are defined in nuanced ways, because that's something that is important, is that you become exact, that you learn how to do things and name things and be technically correct. It's very important in terms of disciplinary learning. So I'm going to pop out of this and back into my semantic feature analysis, which is in my Word document. So here's my handy chart that I made beforehand. And I have this, I'm going to do it on quadrilaterals. So I'm pretending to teach some geometry. And I have here, these are the items. These are the 6 most common regular quadrilaterals. And then I put features. I can have students produce the features, or I can produce them myself. For the purposes of this talk, I did it. I would ask, what are some common features, or what are some things that could describe quadrilaterals? And usually things like congruent sides, congruent angles, right angles, parallel lines. Those are the things that I would want to key on. And your feature analysis might not look exactly like this one, but that's all okay. But then it's a matter of going through this and just sussing things out. So I'll do it across the way. So starting here, squares are equilateral, yes. Do they have 2 pairs of congruent sides? No, because all the sides are congruent. Do they have 1 set of parallel lines? No, because they have 2 sets of parallel lines. Do they have all right angles? They do. So that is a square. Plus, minus, minus, plus, plus. Rectangle, equilateral? No. 2 pairs of congruent sides? Yes, because these sides and these sides are equal. This side and this side is equal. 1 set of parallel lines? No. 2 sets? Yes. All right angles? Yes. So this tells us, so far, the difference between a square and a rectangle is that a square is equilateral and a rectangle is not. And so technically, a square is a special kind of rectangle, but we won't get crazy. A rhombus. Is a rhombus equilateral? It is. Does it have 2 pairs? It doesn't, because it's equilateral. Does it have 1 set? It does not. It has 2 sets. And so far, it's almost exactly the same thing as a square. Actually, it's not almost. It is the same thing as a square, which is why I included this item here. It doesn't have right angles. That's the difference between a rhombus and a square. And technically, a square is a special kind of rhombus, but won't get into that. Trapezoid. Is it equilateral? It's not. Does it have 2 pairs of congruent sides? It does not. Does it have, well, it can technically, but we're not going to get into that. That's not, we won't get that. This top thing and the one leg can be the same, but we won't get into that. 1 set of parallel lines? That is true, yes. 2 sets? No. All right angles? No. You can have 1 or 2, but it can't have more than 2. And trapezoid is kind of the outlier in the, what's one of them? there's two that are kind of weird. Trapezoids are their own little things that just has two parallel lines and then two legs. Parallelogram, is it equilateral? It is not. Does it have two pairs of congruent sides? It does. Does it have one set of parallel lines? It does not, but it has two, and it doesn't have right angles. And if you look at this and you look at these, basically a square is it a square? No, a rhombus is a parallelogram that, what's the difference? Doesn't have right angles. That's it. So that's the difference between a parallelogram and a square. So a square is also a special kind of parallelogram, I believe. Then we get to the last one. This is another outlier. Is it equilateral? Is a kite, and a kite is not equilateral. It has two sets of congruent side, two pairs. This side and this side are congruent. This side and this side are congruent. It does not have parallel lines at all, and it doesn't have all right angles. And so you can see what defines these four things. And this is technical mathematics. So when you talk to students, they know exactly what these shapes are. And they love to, is a square this, is a square that, and you can get into all of this. But this is technically what defines these things. And it's an important thing for students to know in geometry. So, and that's a feature analysis. It works in other content areas too, but I wouldn't use this all the time. This isn't something that's like, I think this is good when you have a lot of like items in a set, but otherwise it gets to be a little bit much. But this is another nice way to sum up a unit. If you were teaching quadrilaterals, you can say, what are the 6 of them and what are the features and how do you compare them? And that's feature analysis. Then we're going back here. Linear array. And linear array, I'm not sharing, but I will share. This is the next thing. It's right here. I'm not even going to do full screen anymore. I'll just show you this. Linear arrays, they're an activity that shows relations of concepts and terms to each other, but in a different way than the feature analysis does. And this does things, they're also called word spectrums sometimes. And this is, you can look up research on using these in this article here by Bintz about teaching vocabulary across the curriculum. I have multiple linear arrays, and I'm going to start with some social studies one, being that I just did a math one. And I have one US political offices. So this one I decided to go with US government as the topic, as the discipline. And so I put 5 offices. These are common US offices. And then I put them by longest term on the right and to shortest term. So rate them: governor, president, representative, senator, Supreme Court justice. And I used to have mayor too, but mayor is weird because some mayors serve 4 years and some mayors serve 2 years, but so I left that out. But for our purposes, representatives serve 2 years, so they're on the short end. Then you go to governors and presidents, they serve 4 each. Then you go to the senators, they serve 6, and then Supreme Court justices, they serve for life. So unless they're really short-lived, theirs is the longest term. Then I did another one, political parties. So I went through political parties and I had us have students rate them from most conservative to most liberal. And these are the parties: Communist, Constitution Party, Democratic Party, Green Party, Libertarian, Republican, and Socialist. And students are usually surprised that there's this many political parties that technically exist in the US, and they have to do a little bit of research about that. But this is not as cut and dried as the first one in terms of the terms. Some of these ideologies and their platforms, some of their items on their planks on the platforms are more conservative, some are more liberal. And it's interesting because if you got students that are informed politically, this gets into a little bit of an argument about what's where and what's really conservative and what's really liberal. And if you're looking for some debate, this is a nice way to learn some vocabulary and foster some debate, and also kind of learn where these things lie in relation to each other. So that's my US government examples. I have another example, and it is in mathematics. And I got a little loosey-goosey with the content areas here. The general one at the beginning is more converting numbers. So I give them numbers like this: a fraction, a decimal, a negative decimal, pi, 450, 0, and another negative mixed number with a fraction. And they have to convert, and I want them to rate them from what's the smallest to what's the biggest. And they need to know kind of where those things lie on the number line. And it's just, this one's a little bit more elementary, I think, but this is an important thing to have in mind when people are doing algebra, is they need to make things into like terms. They need to be able to locate where numbers are and what's lesser and what's greater. And I think this is an easier way to do that. I also went into, I know I work with a lot of math teachers and they love their PEMDAS. This is the order of operations and where do they go at? And I just ruined it because I said PEMDAS. But what do you do first? What do you do last? This is a nice way to reinforce that. First parentheses, then exponents, then multiplication, division, addition, subtraction. That's your order. And this is another way to do that. And there's lots of things, as long as you can kind of put them in some kind of sequential order, being, from volume or amount, or first to last, or chronology. This is a nice activity to put things kind of in relation to each other. It's not just a timeline, it's lots of other things. And I really like it because it's really adaptable to a lot of different topics. And it's quick and easy. This is like not a long activity. This is like something that, be a nice introduction, it'd be a nice ticket out the door kind of thing. So that's my linear arrays. And I'm going to go to my last item, and that is something called the biopoem. That poetry sounds like a thing that's scary because people think it's got to get really technical. Here is the format for a biopoem, and I usually use this as a type of research, honestly, because you need a first name, 4 adjectives that describe the person, son or daughter, who are their parents, what do they love, what do they feel, what do they give, what do they fear, what would they like to see, who, where do they live, and then you give a last name. And you can do this for living people or deceased people. And I'm doing deceased ones just for the purposes of tonight. And I have 2 examples, and I had to do research to do them. And I just wanted to show you, because this is a nice, quick, easy way to do a research paper. I mean, it's not very, it doesn't look very complicated, and it doesn't look like you have to write, pages and pages of material, although you have to put in some work to figure out some of these things. And you have to be imaginative about some of these things, because you have to know something about their lives to know what they love or what they feel and what some of their accomplishments are. So I'm going to show you a couple. I'm going to do, the first one is more of a humorous one, I would say. And we are in Tennessee. So I did Smokey, son of a mama bear and a papa bear, lover of nature, honey, and a healthy awareness of flames, who feels proud in commercials, at home in the woods, and happy when people encircle their campfires with rocks, who gives people a symbol, peace, helpful advice, and hope, who fears wildfires, stray cigarettes, and overzealous hunters who don't recognize him, who would like to see trees grow tall, animals and people coexist peacefully, and you prevent forest fires. You have to do that. Who lived in the National Zoo, but now lives in the hearts of us all, Bear. And this is my biopoem of Smokey Bear, the beloved animal who is the spokesperson for the National Forestry Service, I believe, and was a real bear who I think lived in New Mexico and survived a forest fire and ended up in the National Zoo. And this is his biopoem. I have one more. This is a science one, or actually, this is a dual one. It's technically a mathematics one, but science people like to claim this person too. So I went with this one. Isaac, brilliant, innovative, slightly insane and British, son of Isaac Newton the Elder, that might give it away, and Hina Oskloff, lover of order, science, and figuring out the music of the spheres, who feels enlightened by learning, combative when challenged, and blinded after sticking pokers into his eyes, who gave us calculus, a theory of gravitation and laws of motion, who fears falling apples, irregularities, and being proven wrong, who would like to see Leibniz boiled in oil, Neptune's orbit through the Hubble telescope, and the antics of the Mythbusters, who lived in Cambridge, UK, Newton. And that is my Isaac Newton bio poem. I got a little free with my interpretation at the end. He invented calculus because he wanted to calculate Neptune's orbit. So I'm guessing he'd like to see what it looks like through the Hubble telescope. He took that, he put that in a drawer because he solved that issue. And then years later, this guy named Leibniz came along and said, hey, I made this new math called calculus. And Newton came out and said, I put that in a drawer 10 years ago, buddy. And they had a feud. So I think he did not like Leibniz. And I think he would like the Mythbusters. He seemed like a guy who liked to blow things up or kind of go to great lengths to prove his science. So that's my poem. And like I said, it's kind of fun, but it takes research. You have to put some time into figuring out, the aspects of their life, the specific things, who their parents were, where they lived, and some of their accomplishments. I think that's important. And it's a nice, simple way to do a research project and make something nice that you can display around a classroom or share or even perform. It's something I think it's a nice research project that also has other aspects that I think make it attractive to teachers and to students. And I'm going to go one more time to this PowerPoint. And this is very important. I'm at the end. Thank you. This is how you email me. And I'm hoping that there was something good that you could take out of tonight's talk. And I appreciate you listening. And I hope you have a good day or night or evening or whatever time you're watching this. So take care. And I stop recording.